Untuk bisa mencakup audiens yang lebih luas lagi, keberatan ya kalau saya ngomong bahasa Inggris? Oke ya. So yeah, thank you for welcome to our GO-JEK office in this Sunday morning. My name is Dipta. I'm currently work at GO-JEK as a data scientist. So I'm gonna talk about our data science cases that have been done in GO-JEK and what their impacts and also how we use it on Google Cloud Platform. Okay, let's start. Cool. Basically, this video tells a story about how we at GO-JEK working together with Google in order to handle our exponential growth for the last couple of years. Yeah. I think it's okay. Yeah. So okay. Just that's any question. Just continue to the next slide. Next page, please. Next page. So okay, so GO-JEK started in 2011. We started with a ride-hailing service using GO-JEK, but it was first just a call center without any mobile apps. So the user has to call the call center, ask for the GO-JEK ride, and then it will go to your place and then pick you up. And in 2015, we rolled out our first mobile apps, and also with a couple of other services like of course, started with GoRide and a couple of logistics services like GoSend, GoBox, and food deliveries like GoFood. And within 18 months, we achieved like 900 times of scale in 18 months. Oops. And in 2016, we have other couple of services that relate to our daily lives, like GoClean, GoMassage, and we launched our car ride-hailing service in GoCar. And in 2017, we started at expand more services like e-wallet payment or GoPay. Our GoPay is one of the largest e-wallet service in Indonesia. In 2018, we focused more on international expansion. And for Jirawat, Brisbane and Thailand will come to your country. Yeah. Okay, so currently, how is our situation right now at GO-JEK? And we have about 77 million of app downloads since 2015, and we have about 200,000 of merchants of GoFood, which makes us the largest food delivery service in Asia outside of China. And in Indonesia, we have about 60 cities, about 1 million drivers, and there's about 3 million of people transported daily in our services. And you can imagine we cover about 9 round trips from the Earth to the Moon daily with our fleet. That's what our GO-JEK service. Well, in this kind of huge amount of transactions, huge amount of data that overflowing, it is a very, very huge challenge for us. How do we manage our data? How do we can get insights from our data? How can we take the next step further with our data? That's what our data science team will work on. So, using all of this big data, what kind of impact that we can create actually? I'll give you one example. Last year, in September last year, there was a plan from the Jakarta governor to forbid motorcycles to enter Sudirman Road, which will be dreadful, right? So we at GO-JEK here, from our data, we publish this article. Okay, we say we did a survey, and based on our data, if you commute from Kemanggisan to World Trade Center building in Sudirman, and if you use public transportation, it will cost you 54 minutes. With GO-JEK, only cost you like 50 minutes. So imagine if daily in Jakarta there are about 10 million of people, 10 million people that commute daily. Imagine that how many man hours that can be wasted if motorcycle is forbidden to enter Sudirman. Yep. And you see at the second picture here on the right side, it's a heat map of the GoFood merchants earning. The darker is the higher the higher the earning of the GoFood merchants. If you say the darkest one, the black one is they achieve like more than 200 millions per month. It's so amazing number, right? And if the Sudirman road is forbidden for motorcycles, the driver we will lost about 90,000 trips daily, and for the merchant, we'll lost about 10 billions of Indonesian rupiah daily for GoFood merchant. Using this data, we published an article, and thankfully, the Jakarta governance finally canceled their plan to forbid motorcycle to enter Sudirman. Yep. So that's one of the insights that we can get from our data. Okay, second, let's move on. I want to talk about the data science at GO-JEK. How do we use our data to next step further? Among this data, what can we use actually to what kind of prediction we can create to improve our customer experience and also driver experience? So, in GO-JEK, data science is the first is applied. It's not academic. You can imagine that we don't always do fancy stuffs with data science. What I can tell you is, for example, like deep learning is currently like the buzzwords, right? Deep learning or Tensor Flow and other stuff. Those are and a lot more advanced techniques. It's not always matter as long as it doesn't really solve problems. So at GO-JEK, we really care more about how we apply data science as long as we can solve problems. Sometimes some problems don't need machine learning at all. Just a simple math formula can be solved. So what we really care of it's applied. Second one is integrate with product engineering. No data science product that are meaningful if it cannot be integrated with engineering, because nobody will able to use it if it cannot be integrated with engineering side, right? It will not reach the customer, it will not reach the driver, so can be integrated with engineering is a very important part. The third one is scalable. If you see the scale of amount of GO-JEK data, it is very crucial also that our data product has to be scalable. Yep. So, me in the data science team, first of all, the availability of data is very, very important, because without data, we cannot do anything. Now, at the beginning of the data science team, actually the science at GO-JEK started at 2016, and before that, the data at GO-JEK, we have multiple sources for multiple sources of data. So we have our driver generates speed data every 15 seconds, and we also store data for every single button that our customer pressed during their app. Yeah, we do have all of those data. If you press this button on GoFood, if you press this, you scroll for how many seconds you tap this services. We all have that kind of data. So it's scattered everywhere. We use multiple platforms like the Postgre, we use MongoDB, and so on. And the problem as a data scientist, where do we can get the data? If it's scattered everywhere, if it's using Postgre, if it's using MongoDB, it will be a very wasting time for data scientists to look for the data and ask engineers every time we need data. Many of our engineers are scattered in Indonesia and in Bangalore, and imagine that if we have to ask our engineer in Bangalore every time we need data, hey, I need this GPS ping data, can you help us? So it will be very wasting. And so with Google Cloud Platform, we use BigQuery in order to centralize all the data into a single data platform. We use BigQuery as our main storage, and Kafka as our main event stream. So, has any of you ever heard of Kafka? Yeah. Okay. So, Kafka is basically a stream data that for real-time data. So, every developer, every engineer, they can publish or subscribe to necessary data in a single stream in a single stream platform, which is Kafka. And we also have Google Cloud Storage. That's to save all of the world data as well. So using these three components, all of the data in GO-JEK is centralized. So we can have single source of data, single truth of data, and it's organized. And we encourage all of the data owners, like the engineers, if they create some apps, we encourage them to stream their data to Kafka and publish them to BigQuery. And the benefits for them, we provide monitoring for their data. We provide archival monitoring and security as well, because by using this centralized data, we have a centralized authentication as well. So only using one single GO-JEK Google account, they can access all of the data. It doesn't need to have, for this Postgre, you have to have another account. For this MongoDB, you have to have another account. It's not like that. So it's all for security. We can have all centralized authentication as well. So it's very secure. Yep. Now, if I want about the impactful data science cases, I'd like to tell a couple of cases that in data science team at GO-JEK. The first is the allocation. Before, this is the very first data science team project at GO-JEK. Before that, the order at GO-JEK, when a customer press a booking at GO-JEK app, each driver will have to vote, and the quickest step is the one that will get the order. It's not very smart, right? You just make the driver keeps looking at their phone and then tap as quick as they can, and so it's not very smart. So we came up with the idea to create a smart allocation, and which means if a customer order a booking, which driver that we have to assign. That's the answer. So imagine that there's a customer, and you can see that there are a couple of drivers available here. It turns out the yellow one here, this driver is about to heading home, because based on his historical data, at this hour he may usually go to his home area. And the blue one is on trip, so we cannot assign him. And that gray one, he has a very high estimation time. So in this problem, we realized that the distance between one customer to a driver, the closest distance is not always the most important thing. So imagine if you order something and turns out the driver is at the other side of the road, even though that the distance is very close, he has to make a U-turn and it may take a longer ETA. So that kind of driver will not be prioritized in this allocation. And in this allocation, yep. So we create this allocation model. We use a couple of other features for this allocation. There are driver-related features like their estimated time, their speed, currently their direction, whether they're going home or not, and our customer-related features like customer profiles, what kind of services do they usually take, where do they usually go at this time in hour. So, for example, if your home is located in Bekasi, and usually in the morning you go to the central part area of Jakarta, our model will know that, oh, this morning usually go to this area, so we will assign you a driver that will usually go to this area. And also the same, if in the evening, your home is in Bekasi, for example, so it's very likely that we will pick the driver that in the evening will also go to Bekasi. So that's our allocation system. There are a couple of other features, there's about the hundreds, and all of these features, again, centralized into our foundation, our data foundation. It's in BigQuery. So all the projects are. So we have the same single thread of data, and so if you look at, so anybody can have the same data without any hassle. Second, it's very interesting, the fake GPS detection. This is very challenging projects because turns out, and sadly, there are so many of our drivers are using fake GPS to fake their location in order to get a booking faster, and it is our responsible to prevent them to get bookings, because it will get a bad experience for customer, and also it's not fair to the drivers that are not using fake GPS. So we use a couple of features in here, but for example, there are just these two visualizations on the left and on the right. The left one might be this driver do not use fake GPS. We look at their pattern. Oh, I think it's pretty normal. You look at this goes from here to here to here. Okay. The second one, you see, the driver can jump for about 106 km per hour. Can you imagine if there is any motorcycle that can jump 100 km per hour in Jakarta? It's impossible, right? So it's very likely that's using fake GPS. So we use every single ping GPS data for each driver to detect whether they are using fake GPS or not. We can look at their data pattern. We can look at their speed among this between each ping GPS, and using all of those features, about hundreds of features also, we're very likely to get 80% of accuracy of predicting whether they are using fake GPS or not. And then we can send them warning. We can send them, if you keep using this fake GPS, we will suspend you, something like that. So with this project, we successfully cut down most of the fake GPS users and improve the customer's experience. And third one is one of the most exciting project at GO-JEK, which is the search pricing. As you can see here is the map of Jakarta, and every single cell represents the search spectrum of that area. The red one has the highest search pricing, which means it's like a multiplication factor for the price of one driver. And we encourage the driver to go to the red area because they are where the high demands are. So the yellow one you can see is it's also slightly higher. The blue one may not be so high, so driver may not need to be there because there's no demands. So using this case, driver will know where they should go. Driver will know which area that really matters the most in the terms of demands. Which one have the higher demands in here? Whether it's a low demand, medium demand, or high demand. Okay, but there's a problem in this project. Why? Because Jakarta traffic is so bad. I think all of us can agree on that, right? And if we say that in the area of SCBD there is a high demands, but the driver needs about 20 to 30 minutes away to go to that area, it is likely that when the driver arrives in that area, the area is no longer in a red cell. The demands are already low. So what we're going to do is we create a forecasting demand. So we forecast the demand in each area, in each time slot. So, for example, we use a lot of features like the supply, the history of the supply, the history of the demands, how the traffic, how the weather, whether it is raining or not in that area, and number of clicks of apps if among customers in that area, and also hundreds of other features we use to forecast the demand using Tensor Flow. So we can predict with this model data, we can predict the demand in a certain area, in a certain time slot. It'll be simply like this. If you see on there are green line and yellow line. The yellow line is the real demand during that hour. This is time minutes, and then the X, and the Y-axis is the number of demands, which is normalized 0 to 1. You see that the yellow one is the real actual totals of the demands in certain area, and the green one is our prediction of forecast. By using this, we can predict that this area will be in high demand in 1 hour, for example, like that. So we can tell our driver in advance for them to go there. So they will be ready. They will be ready in that area, and before the demand goes high. And one of the interesting part in here, this Tensor Flow model, it consumes hours and hours. It could take days to train, and if we just using a single local machine, it will not be possible. So one of our data scientists tried this on building a Google VM, open 100 gigs of RAM, but still it's not sufficient and it failed. We also consult our engineer to try to create a Spark cluster and to integrate to train this TensorFlow, but still it fails, and because it consumes a lot of memories, it consumes a lot of time. The solution is we use a Google Cloud platform called Cloud ML Engine. Why do we use that? Because Cloud ML Engine is really scalable. It's a manager for TensorFlow. So it's automatically scalable. When you train these certain features, we can pick how many CPUs, where we can use GPUs or TPUs, TensorFlow processing units, and it's also scalable in the terms of memory. So in terms of memory, it will automatically scale in the memories that we need to train this model. So we don't have to worry at all about whether the infrastructure for this TensorFlow is sufficient or not. So this is the data flow from. We got our features. Our data captured in Kafka, and it is stored in Cloud Data Flow, stored in BigQuery, and it will be put in Cloud ML Engine. And Cloud ML Engine will be sending two directions of data from Cloud Data Flow. For example, the weather prediction has changed. Turns out there's a new data that there will be raining in 1 hour. So that means from this Kafka, it will stream the data of the weather. It will be read by the stream inference here, and then it will speak to the Cloud ML Engine that, it will be raining. Okay, so we need to retrain again. So it will talk to the Cloud ML Engine, and then it will publish back again the new prediction. Since there's a new data, it will say that in 1 hour that's going to be raining. We have to retrain the forecasting, and then we have to republish again the data back to Kafka. So after we publish that in Kafka, or the driver app can also have the most updated heat map in their app. It's really helpful for the drivers, and our customers, because on the driver side, they know where to go. Which potentially make them can earn more. They can have a higher earnings. And for the customer, they don't have to worry because we exactly know that which area that is possibly will get high demands. Okay. Yes. So to wrap up, use EC for data foundation. This is a single source of truth, and data science cases using Google platform. We have improved the customer and the driver experience. And yep, that's it from me. Thank you. Oh yeah.